Hi, my name is Alamuta Dessa. I am medicinal chemist from Addis Ababa University School of Pharmacy. This is the medicinal chemistry of antifungal agents. We will see the structure activity relationship of some antifungal agents. Please don't forget to subscribe and like and share it. What are antifungal agents? Antifungal agents are drugs that selectively eliminate fungal pathogen from a host with minimal toxicity to the host. These antifungal agents, based upon the application, they may be topical agents or systemic agents. Also, based upon their effect, they may be fungicidal or fungistatic agents. Fungicidal, they are compounds or drugs that can kill funguses, but fungistatic, they inhibit the growth of funguses. There are four broad classes of these antifungal agents. This includes Pauline antifungal drugs, azole antifungal drugs, allyl amine antifungal drugs, and miscellaneous classes, or you can say other antifungal drugs which are not classified on those which are mentioned earlier, because they are structurally different from the other three. Let's see the first, called Pauline antifungal agents. The Pauline antifungal agents, they are compounds that contain alternating conjugated double bonds. Conjugated double bonds are double bonds which are separated from each other by a single bond. For example, here we can see in this example, here there are double bonds. All the double bonds, they are separated with single bond. Such type of double bonds, they are termed as conjugated double bonds. Pauline antifungals, they have these conjugated double bonds. Conjugated double bonds, they are very important for their antifungal efficacy. This Pauline means, poly means many. En means alkene. Therefore, these are drugs that contain many double bonds, many carbon to carbon double bonds. That's why they are termed as Pauline antifungal agents. They are amphoteric because they have in structure, they have the primary amino group. Here we have the structure, we have the primary amino group here, the primary amino group here. Also, they have acidic group here. Therefore, they have both acidic and the basic particles. Because of this one, they are termed as amphoteric. Amphoteric are compounds that can behave either as basic or acidic compounds. The class, some of the drugs that are listed under this Pauline antifungal are amphotericin B, nystatin, pimarisine, rimocidine, and philippine are common type of drugs that are categorized or classified under Pauline antifungal. Pauline antifungal, they are purely soluble in water. Somewhat also these compounds, they are unstable compounds because of their extensive unsaturation. These drugs, they will interact with sterols in cell membrane, then they will inhibit the synthesis of this membrane in fungus. They are fungicidal compounds. Here, this is one example of or general structure of the Pauline antifungal. Here we have a macrocyclic structure. Macrocyclic, it is a bulky structure that contain a large number of carbons or atoms in a cycle. Generally, these Pauline antifungal drugs, they are lactone ringed. Lactone ringed. They are polycyclic molecules that contain a lactone ring. Lactone means if there is an ester in a cycle or in a ring, this ester in a ring is known as lactone. Therefore, Pauline antifungal, they are macrocyclic lactone containing compound, or they are lactones. Generally, most of these compounds, they may be distinguished from each other. Number one, by their configuration of the double bonds, they may differentiate from each other. Number two, they may be differentiated based upon the configuration of the OH groups. Or number three, or they may be classified or distinguished based upon the number of OH groups and the double bonds. The other one that can distinguish Pauline antifungal agent is the size of the macrocyclic ring. These are where the diversity of Pauline antifungal was erased. Therefore, look this structure. In this structure, in this Pauline structure, we have this structure. We have hydrophilic parts. Hydrophilic part is the part that contain hydroxyl groups. Here we have many hydroxyl groups. This part is known as hydrophilic, water-loving part. And we have hydrophobic part. We have hydrophobic part, the conjugated double bonds. This is hydrophobic part or lipophilic part. It is known as water hating part. Therefore, these compounds, they have both hydrophobic part and hydrophilic part. Therefore, such type of compounds that contain both portion, hydrophilic or hydrophobic portion, they are termed as amphiphilic or amphipathic compounds. Therefore, these Pauline antifungals, they are amphipathic. Amphipathic or amphiphilic means compounds containing both hydrophilic and hydrophobic or lipophilic portion. Generally, these compounds, they have the macrocyclic core. This is very important. Also, they have the sugar. There is a mycosamine sugar. Also, we have amino containing sugar parts. They are very important for antifungal activity of these compounds. Look here, why these compounds, they are called amphoteric, because they have acidic part here. There is an acidic part. Also, we have a basic primary amino group here. We have the basic amino group here in the structure. This is the basic amino group. Therefore, they are called amphoteric because they have acidic carboxylic group and primary amino group, which is basic. Due to this one, they are termed as amphoteric. Here we have mycosamine part. We have mycosamine sugar part. Here we have. This is the mycosamine sugar. Also, here we have another sugar in the ring. Here we have another sugar, 6-membered ring sugar here. This is also another sugar. Therefore, it has two sugar. These two sugars, they are essential for antifungal activity of Pauline. Here for the summary for you, hydrophilic part, that is polar part, and we have non-polar part, which is the colored one. Here the green one is hydrophilic part, that is water loving part, the polar part or the polar end. And we have the lipophilic or hydrophobic portion, non-polar portion, which is colored red. Therefore, these are very important structures of Pauline antifungal. We have amphotericin here. This is a structure of amphotericin. This is the general structure of amphotericin. Also, we have the structure of nystatin, another Pauline antifungal agent here. Pauline antifungal agent. These are the structure of nystatin. Nystatin is the first Pauline antifungal agent that is used for treatment of different types of fungal pathogens. Generally, in the structure of this Pauline antifungal, increasing conjugation always will increase the potency. Activity will regularly increase. Here, in the case of amphotericin B, there are about seven conjugated double bonds. 1, 2, 3, 4, 5, 6, 7. The conjugated double bonds, they are separated with single bond. Therefore, for Pauline antifungal agents, increasing conjugation will increase potency and decreases the toxicity or side effect will decrease, mainly in mammalian seed. Therefore, increasing conjugation, increasing the double bond conjugation in the series of Pauline antifungal will increase the potency and decreases the toxic side effects. But in the case of nystatin, look the structure of nystatin here. This is the structure of nystatin. Here we have the structure of nystatin. Nystatin has 1, 2, 3, 4, 4, 5. There are 5 conjugated double bonds. The other double bonds, those that are colored red, they are not conjugated. They are isolated double bonds. Therefore, here in the case of amphotericin B, there are 7 conjugated double bonds. But in the case of nystatin, there are about 5 double bonds that are conjugated. Therefore, increasing conjugation will increase potency. Therefore, amphotericin is more potent Pauline antifungal than nystatin. The second class of very important compounds that are used as potent antifungal agents are azole antifungals. What are azole antifungal? These are significant agents for treatment of fungus. Therefore, here we have the structure of azole antifungals. We have a structure of azole antifungal. We have large number of azole antifungals in clinical use. This is the general structure for azoles. Azoles are 5-membered heterocyclic rings. They may be with 3 nitrogen or with 2 nitrogen. Here, look the structure of this compound. We have 5-membered, 1, 2, 3, 4, 5. 5-membered heterocycle. It contains different elements in addition to carbon. Nitrogen and other carbons. Therefore, it is heterocyclic compound. Here, we have X here. X, it may be carbon or nitrogen. When X is carbon, it is known as imidazole. When X is nitrogen, they are called triazoles. Therefore, commonly the azoles, they may be imidazoles with 2 nitrogen in 5-membered ring or with 3 nitrogen in 5-membered ring. This imidazole or the triazole is very crucial for antifungal activity, very essential, very important. By the way, these compounds, they are fungistatic compounds. They inhibit the biosynthesis of ergosterol. Here we have the structure activity relationship of antifungal agents, mainly azole antifungal agents. Look, this is a general structure of antifungal agents. This is a structure of antifungal azole. This is the general structure. This is a general structure. it has the aromatic ring, it has side chain, also it has azole rings. By the way, for activity, for potency, for azole antifungal, number one, the azole is crucial, critical for activity. That azole, it may be imidazole or triazole. Generally, triazoles, they are more potent than azoles. Increasing the number of triazole ring, by the way, increases potency if the distance is kept between the azole ring and the halogen containing aromatic ring. Number two, very important thing is that the phenyl rings, aromatic rings, they are very essential for activity, antifungal activity. The aromatic ring. Here we have aromatic ring. By the way, those compounds that contain 2 to 3 aromatic rings, they are the most potent. In fact, one aromatic ring that contain halogen is also important. But if the number of phenyl ring or aromatic ring is increased, meaning that 2 or 3, the activity also will increase. This is the second very important thing for potency. Thirdly, substitution of halogen on one of the phenyl ring. Substitution of halogen on one of the phenyl ring. I say that the number of phenyl group for azole, it may be 1, 2, or 3. 2 and 3 aromatic ring or phenyl containing azoles, they are more potent than one aromatic ring containing compounds. But there are also other factors that will affect the potency of these compounds. Look, the third very important thing is that introduction of halogen atom. Introduction of halogen atom, either in ortho or para position. Substitution in other places will decrease antifungal potencies. Antifungal potencies, meaning that meta substitution will decrease potency. Here, this compound, they may contain only ortho or diortho. Ortho or diortho, or ortho and para substitution. Generally, the ortho para substitutions and ortho only, one ortho substitution, they are potent compounds. Meaning, I am saying they are equally potent. If you have one compound that contain ortho only, ortho halogen, for example, maybe chlorine, ortho chlorine, and if you have another compound that contain ortho in the para, they are equally potent if they are the same substitution. Chlorine, chlorine. One orthochlorine, the other ortho and the para. They are almost equally potent. There is no significant difference in their activity. But only para is lesser than, only para substitution is lesser than para is here. Therefore, only para is lesser than only ortho and ortho and the para substitution. That is very important. The other very important thing that will affect the activity of many of antifungal azole is the distance between the halogen containing, this is halogen containing aromatic ring, and the azole ring. That distance is critical for antifungal potency. Here we have two carbons. Look, these are the 2 carbons. 1, 2. That distance is crucial for activity. If you increase the distance between the halogen containing aromatic ring and the azole ring, this will decrease activity. Decrease will the activity. Therefore, the most potent azole antifungal agents, they contain azole ring. Generally, in triazoles, they are more potent, many times, several times more potent than imidazoles, number one. Number two, the number of phenyl ring is essential, 2 to 3 phenyl rings for maximum. Number three, halogen substitution, ortho, para, or only ortho. It's very important. Also, another one is that para is also important, but para is less potent than only ortho or ortho para substitution. And the distance between the aromatic halogen containing aromatic ring and the azole ring is important. Another very important thing is that generally fluorine substitutions, they are greater than chlorine substitution. Also sulfites or sulfuric SO3 minus, they are also potent here at either of the two position or both position. These are the structure activity relationship of antifungal agents. Here we have the activity. The activity here is said that this is very important. Therefore, triazoles, they are many times more potent than imidazole. When X is in the ring, when X is nitrogen, it is greater than X is carbon, meaning that here in the structure, in the azole structure, when it is X is carbon, it is less potent than X is nitrogen. This is because the amidine nitrogen atom at N3 position is believed to inhibit the activation of the molecular oxygen. That's why. And it will prevent the oxidation of the steroidal substrate by the enzyme. These are very important structures of these azole antifungals. Here we have many azole derivatives: clotrimazole, we have chlorimidazole, also we have ketoconazole. This is ketoconazole is the first orally active antifungal agent. It's very important compound. It has a 2-chlorine ortho in the para substitution. Also we have different derivatives of azole antifungals. Here we have itraconazole and fluconazole. In the case of itraconazole and fluconazole, fluconazole has 2 fluorine groups. Itraconazole has also it has 2 halogens, chlorines. Fluconazole is considered as more potent than itraconazole because fluconazole, number one, it has fluorine at 2 and 4 position. Itraconazole has it has chlorine at 2 and 4 positions. 2 and 4 position. That's why fluconazole is more potent than itraconazole. The second one is that fluconazole, it has 2 triazoles which are separated with the halogen containing aromatic ring with 2 carbons, but itraconazole has only one triazole ring in its structure. Because of these two reasons, fluconazole is more potent than or more active than itraconazole. Here also another very important thing is that look the structures between ketoconazole and the structure between ketoconazole and itraconazole. Both of them, they have halogen. Look the structure of ketoconazole, halogen. It has chlorine. It has imidazole ring. But in the case of itraconazole has triazole ring. Therefore, triazoles, they are more potent than imidazoles. Here it has imidazole ring, therefore it is more potent than ketoconazole. That is a very important point. By the way, in the structure of itraconazole, there is another imidazole. Yeah, another imidazole ring. Look here. This is another imidazole ring here. Look, the distance between between this imidazole ring and the aromatic group that contain halogen is it's not two carbon, it is not two atoms. Therefore, this triazole ring, which is found distant to aromatic ring, has lesser effect in activity. To have effect, it must be separated with two carbons. That is essential. That is important. This in the structure of fluconazole. Fluconazole, it has two triazole rings. Also, there is a OH group on fluconazole. This OH group is very important. It is important for water solubility. It is highly water soluble substance. The presence of the OH is essential and it will provide better water solubility for this compound. These are some of newer antifungal azole agents. Most of them, they were derived or developed based up on those structure activity relationship. Therefore, we say that for better potency, azole antifungal agents, number one, the presence of azole is important. Mainly triazole, they have greater potency than imidazoles, number one. Number two, the aromatic rings, they are important. The number of aromatic rings, mainly 2 and 3, they are the most potent. If there are 2 or 3 aromatic rings, one is halogen containing, they will be the most potent. Thirdly, the halogen substitution, either of 2, 4 or 2 only. Also, in fact, substitution at the para position also increases potency, but is less potent than those that are substituted at 2, 4 or 2 only. The fourth one, the distance between the halogen containing the aromatic ring and the azole ring, it is also essential for activity. And the last very important thing is that the type of halogen also, it has effect on antifungal activity. Generally, fluorine is greater than chlorine as an antifungal agent. The other class of antifungal agents, they are called allylamines. This includes naftifine, terbinafine, butinafine, and birolfine. These are potent ergosterol synthesis inhibitors. The first compound is terbinafine. What is terbinafine? Terbinafine is the important compound that is also used as a fungicidal compound. Here you can see, here there are naphthalene ring. By the way, it is called terb. Terb means there is tertiary butyl group. Terb means it was derived from the presence of tertiary butyl group. Also, here we have NAF means on terbinafine, NAF means it indicates the naphthalene, the presence of the naphthalene group. This is naphthalene group. The ending IN indicates terb, terb, means tertiary, BI indicates tertiary butyl group, and NAF indicates naphthalene group. INE indicates, the last INE indicates the tertiary amine groups. In the structure activity relationship of this allyl amine compounds, number one, the tertiary amine group is very important. Here we have tertiary amine group. Here also we have tertiary amine group. Here also we have tertiary amine group. These tertiary amine groups, they are very important for penetration, for directing a drug to the site of action. Very important, mainly tertiary amines. Also, there are two hydrophobic portions. Number one, the naphthalene group and this group. They are very important for providing lipid solubility, lipophilic nature for a compound. They are essential. Also, the distance between the lengths between the linking group is very important, meaning that the linking group is here nitrogen. The link group between the two hydrophobic portion, they are very important. These are the structure activity relationship of allylamine antifungal. Other antifungal agents like fluorocytosin or flucytosin, this is anti-metabolite antifungal. It's the only agent, by the way. There are a large number of anti-metabolite or anti-folate antibacterials we have. In the case of anti-protozoa, we have large number of anti-folate or anti-metabolite anti-protozoal compounds we have. For treatment of fungal, we have one anti-metabolite. Anti-metabolites are, sometimes they are also termed as anti-folates or folate antagonists or folic acid antagonists. They are structurally similar with the metabolite which can be antagonized. Therefore, this is also another anti-metabolite drug that is structurally similar with cytosine. The other compound commonly used is grisofulvin. Grisofulvin, this is the structure of grisofulvin. It has three rings. There are structures, different structures for this compound. For possible stereochemistry, only gives active enantiomer for this compound. Whenever chlorine, here we have chlorine substitution at 7th position. Substitution of that chlorine with fluorine will retain activity. The activity is similar. But if chlorine is substituted with bromine, this chlorine, if it is substituted with bromine or hydrogen, the activity will decrease. Also, substitution of C5 substitution with any group. Here we have C5 position. C5 is this. Therefore, substitution with halogen and any group will decrease activity of grisofulvin. Also, replacement of methoxy group on ring C. Methoxy group. Here we have methoxy group on ring C. There is a methoxy group. Therefore, substitution of this methoxy group on ring C with propoxide group or larger groups or butoxy group will increase activity. Therefore, these are the structure activity relationships of some of common type of antifungal agents. Another one is cycloproxy. This is another very important type of antifungal drug that is also used for treatment of fungal pathogens. These are the mechanism of action of some of the antifungal agents. You can go through. Thank you so much.